So, good evening. This is the ninth live discussion session of the course Geotechnical Engineering 1. Uh, the session 8 has been skipped due to unavoidable circumstances, which will be taken tomorrow. That chapter was about the stress distribution in soil, and this chapter is about the Boussinesq theory. So I think someone has joined, but currently he has left. So I'll straight away start from the PPT. Yes. So there is a problem with the internet connectivity today. So I think someone has joined. Anyway, uh, I hope the PPT is visible. Those who have joined, can you hear me? Hello. Okay, fine. I'll start with the PPT itself. Yes, so good evening everyone. This is the ninth live discussion session of the course Geotechnical Engineering 1. The topic of today's discussion is Boussinesq theory. This is with respect to the stress distribution on the surface. Like the regular classes, like the previous classes, this session has some MCQs. It has some numericals. It has many, much more number of numericals. So those of you who have joined, I will dictate the numericals. Please note down the numericals very carefully, and I will give you some more time today, around 15-20 minutes, because you have to solve the numericals using the appropriate formulas for line load, for rectangular load, for circular loading, for this Boussinesq theory. Okay, so after you solve all the numericals, all the questions, I'll again give you some time. Dheeraj. Am I audible? Dheeraj, am I audible? And is the PPT visible?
One minute, sir. Just yeah, you are audible, but still PPT is not visible.
PPT is not visible. Okay,
Yeah,
I'll
yeah. Now visible, sir.
now
Now
visible, right?
visible.
So PPT is visible. It is
Yes.
showing week 9 Boussinesq theory. Okay,
Yes. Yes.
and I'm audible.
Yeah.
Okay, fine. So
Yes.
this is the ninth discussion session. As I was saying that this session has many number of numericals. The questions are less, but the numericals are more. So at first I will dictate, and this chapter of stress distribution only deals with the Boussinesq theory, and the rest part, the other part problems of the stress distribution in soils, will be dealt with in the tomorrow's class, which is the 8th live discussion session, because the last Friday's class has been postponed to tomorrow, right? The last Friday's class had been postponed to tomorrow. So the part except the Boussinesq theory will be discussed in tomorrow's session from 6 to 8, and today it is specifically the stress distribution due to Boussinesq theory. Now this chapter has some, this live discussion session has some MCQs and numericals. Again, as you have joined now, I will just tell you to First of all, write down the questions as I dictate them. Okay, like the previous sessions, please write down the questions as I dictate them. Write down the numericals very carefully. I'll give you some time to solve all the numericals, and then I'll start discussing the solutions. Okay, so without a further ado, I'll start discussing. I'll start dictating the questions. This is the 9th live discussion session of the course Geotechnical Engineering 1. The topic is Boussinesq theory. So the first question is, yes, according to Boussinesq theory, the soil mass is, according to Boussinesq theory, the soil mass is, your options are homogeneous and isotropic, first option. Second option, homogeneous and anisotropic. Third option, heterogeneous and anisotropic. Sorry, heterogeneous and isotropic. And fourth option is heterogeneous and anisotropic. So in the Boussinesq theory, as you might know, that there are some assumptions to be considered. Okay, so these assumptions, which among these four options is an assumption in the Boussinesq theory with respect to the properties of soil mass? I'll repeat the question. According to Boussinesq theory, the soil mass is, first option, homogeneous and isotropic. Second option, homogeneous and anisotropic. Third option, heterogeneous and isotropic. And last option is heterogeneous and anisotropic. Okay. Okay. Next question. Yes. At constant r, r is the radial distance, and the value of the constant value of r is 1 unit. At constant r, that is r equals to 1 unit, the vertical stress is maximum at z equal to, z is the depth, okay, depth in meters, of course, the depth in meters. So at constant r, r equals to 1 unit, the vertical stress is maximum at z equal to, first option, 1.225, second option, 0.1225, third option, 2.124, last option, 1.625. I hope you are familiar with the concept of Boussinesq theory and stress distribution. You know the formulas, the Boussinesq influence factor. Hello? Are you familiar with the concept of Boussinesq theory and the Boussinesq influence factor and the respective formulas and the problems? I repeat the question. At constant r, r is the radial distance. At constant r, and the constant value of r is 1 unit. At constant r, the vertical stress is maximum at z equal to, z can be in units or commonly taken units as meter. So if r equals to 1 meter, z will be how many meters? To obtain the maximum magnitude of the vertical stress. First option 1.225, second option 0.1225, third option 2.124, last option 1.625. Okay. Okay. Next question. Yes. At zero radial distance, the value of Boussinesq influence factor is, I repeat, at zero radial distance, the value of Boussinesq influence factor is, first option 0.647, second option 0.478, third option 0.888, last option 0.239. Has anyone else joined? No. Okay. I repeat the question. At zero radial distance, someone has joined. I repeat the question. At zero radial distance, the value of Boussinesq influence factor is, first option 0.647, second option 0.478, third option 0.888, last option 0.239. Okay. Okay. Next question. The Boussinesq influence factor is a function of r, z and q. R is the radial distance, z is the depth and q is the load. The Boussinesq influence factor is a function of r, z and q. Is this statement true or false? I repeat the statement. The Boussinesq influence factor is a function of r, z and q. Is this statement true or false? Okay. Next question. The change in vertical stress in a soil mass estimated by Boussinesq equation when Poisson's ratio of the soil reduces by 20% will be. I repeat, the change in vertical stress in a soil mass estimated by Boussinesq equation when Poisson's ratio of the soil reduces by 20% will be. Your options are increase by 20%, reduction by 40%, increase by 50%, or no change. I repeat the question. The change in vertical stress in a soil mass estimated by Boussinesq equation when Poisson's ratio of the soil reduces by 20% will be. First option, increase by 20%. Second option, reduction by 40%. Third option, increase by 50%. And last option is no change. Okay, so these were the 5 short questions combining MCQ and true false statements. Now there are 10 numericals. Please write down the data very carefully, and I hope you can use the formulas for the Boussinesq theory. You can apply them to solve the problems. Next question. A circular area of 7.5 meter in diameter on the ground surface carries a uniformly distributed load 3 kilonewton per meter square. Find the intensity of vertical pressure below the center of the loaded area at a depth of 6 meter below the ground surface. Please note the depth is given as 6 meter. To find out the pressure, vertical pressure below the center of the area, loaded area, the depth is 6 meter. I repeat the question. A circular area of 7.5 meter in diameter on the ground surface carries a uniformly distributed load 3 kilonewton per meter square. Find the intensity of vertical pressure below the center of the loaded area at a depth of 6 meter below the ground surface. I hope the question was clear. I'll go to the next question. Yes. A circular area is loaded with a uniform load intensity of 100 kilonewton per meter square at ground surface. Calculate the vertical pressure at a point P so situated on the vertical line through the center of the loaded area that the area subtends an angle 90 degree at P. I repeat the question. A circular area is loaded with a uniform load intensity of 100 kilonewton per meter square at ground surface. Calculate the vertical pressure at a point P so situated on the vertical line through the center of the loaded area that the area subtends an angle 90 degree at P. Okay. Next question. Yes. A concentrated load of 200 kilonewton acts at the ground surface. Find the intensity of vertical pressure at a depth of 10 meter below the ground surface and situated at the axis of loading. What will be the vertical pressure at a depth of 5 meter and a distance of 2 meter from the axis of loading? So there are two parts. In the first part, we have to find out the intensity of vertical pressure when the depth is 10 meter and it is at the axis of loading. In the second part, same thing, you have to find out the vertical pressure at a depth of 5 meter, but here the distance from the axis of loading is 2 meter. There is a radial distance. Please let me know if my if the volume has increased now, because I think there was a problem with the OBS. Is the volume same or it has increased or decreased? Hello?
No, sir, volume is good.
Volume is same, right? It has not increased or decreased.
Yeah, yeah. Yes, yes.
Okay, fine. Okay, so I repeat the question. A concentrated load of 200 kilonewton acts at the ground surface. Find the intensity of vertical pressure at depth of 10 meter below the ground surface and situated at the axis of loading. What will be the vertical pressure at a depth of 5 meter and at a distance of 2 meter from the axis of loading? Okay. Chalo. Next question. Yes, a rectangular area 3 by 1 meter, is 3 meter is length, 1 meter is depth, is uniformly loaded with a load intensity 100 kilonewton per meter square at the ground surface. Calculate the vertical pressure at a point 4 meter below one of its corners.
Excuse me, sir.
Yes.
By which method, sir? This question answer.
You can do it by any method, like converting into a single point load or using the long formula, for rectangular
Long.
load.
Okay.
You can do it by
Okay.
any
Okay.
method. I will show you one method in one sum, another method in another sum, and you
Okay.
can just check and compare your answers. Doesn't matter. Okay.
Okay, sir.
I think the
Okay.
answers will vary only by a fraction of decimal, something like that. So any method will be accepted. Okay. No
Okay.
worries. I repeat the question. A rectangular area 3 by 1 meter is uniformly loaded with load intensity 100 kilonewton per meter square at the ground surface. Calculate the vertical pressure at a point 4 meter below one of its corners. Below one of its corners. Okay. Okay. Next question. Uniform intensity of loading at the foundation level of a building 10 meter in width and of infinite length is 100 kilonewton per meter square. Calculate the vertical pressure under the center line of the footing at a depth of 10 meter. I repeat the question. Uniform intensity of loading at the foundation level of a building 10 meter in width and of infinite length is 100 kilonewton per meter square. Calculate the vertical pressure under the center line of the footing at a depth of 10 meter. Okay. I hope the question was clear. Okay, just give me a moment. Complete. 1, 2, 3, 4, 5, 6, 7, 8. Next question. Yes. A point load of 100 kilonewton acts on the ground surface. Find the maximum vertical pressure on a vertical plane at a distance of 2 meter from the loading axis. I repeat the question. A point load of 100 kilonewton acts on the ground surface. Find the maximum vertical pressure on a vertical plane at a distance of 2 meter from the loading axis. Please keep in mind it is a point load. Okay, point load of 100 kilonewton acting on the ground surface, and to find out the maximum vertical pressure. To find out the maximum vertical pressure. Okay. Okay. Next question. Yes. A concentrated load of 50 kilonewton acts vertically at a point on the ground surface. Compute the ratio of vertical stresses at depths of 3 meter and 5 meter vertically below the point of application of load. I repeat the question. A concentrated load of 50 kilonewton acts vertically at a point on the ground surface. Compute the ratio of vertical stresses at depths of 3 meter and 5 meter vertically below the point of application of load. Okay. Next question. A rectangular area of 2 by 4 meter carries a UDL, that is uniformly distributed load, of 8 ton per meter square on the ground surface. Find the vertical pressure at 5 meter below the center and corner of the loading area. Again, this sum you can do it, you can use any formula, like whatever is feasible, whatever is applicable, using the long formula, using the chart, not the chart, sorry, the table for getting the influence factor, or converting it into point load, equivalent point load. Okay, you can do it in any method. I'll show you one, but the answers will be similar if not the same. And the pressure you have to keep it, you can keep it in ton per meter square only. Okay, there is no need to convert it into any other units. I repeat the question. A rectangular area of 2 by 4 meter carries a UDL of 8 tons per meter square on the ground surface. Find the vertical pressure at 5 meter below the center and corner of the loading area. Here you can use any formula that can be applied with respect to the loading on UDL on rectangular area. Okay, so next question. Yes. Find the intensity of vertical pressure and horizontal shear stress at a point 4 meter directly below a 20 kilonewton point load acting on the horizontal ground surface. What will be the vertical pressure and shear stress at a point 2 meter horizontally away from the axis of loading but at the same depth of 4 meter? I repeat the question. Find the intensity of vertical pressure and horizontal shear stress at a point 4 meter directly below a 20 kilonewton point load acting on the horizontal ground surface. What will be the vertical pressure and shear stress at a point 2 meter horizontally away from the axis of loading but at the same depth of 4 meter? So there are two parts of the question. I hope we have written down the question very carefully. Okay, there will be altogether there will be 4 answers. The first part will have 2 answers, the second part will have 2 answers. There will be 4 answers. Okay. Last question. The vertical stress at some depth below the corner of a 1 meter by 1.5 meter rectangular footing due to a certain load intensity is 100 kilonewton per meter square. What will be the vertical stress in kilonewton per meter square below the center of a 2 meter by 3 meter rectangular footing at the same depth and same loading intensity? I repeat the question. The vertical stress at some depth below the corner of a 1 meter by 1.5 meter rectangular footing due to a certain load intensity is 100 kilonewton per meter square. What will be the vertical stress in kilonewton per meter square below the center of a 2 meter by 3 meter rectangular footing at the same depth and same loading intensity? Okay. So I hope the questions were clear. If you have missed some questions for joining late, no worries. I will be discussing them all together. You can note them down. So I guess I'll give you today 15 minutes. Will that be okay? To solve all the questions, or do you need more time?
Yeah, that's okay, sir.
Okay, so 15 minutes I'll be giving you. I'll start at 7:10. Okay.
Yeah,
And
yeah.
I generally
Can you keep
join
the first question, sir?
first question. First
Yeah,
question.
open it and then close. Yeah, that's all, sir.
Yeah. And I generally join through my mobile network, but the network connectivity is down today. Like the phone's network is not working today. So if I get disconnected, okay, please stay in the meeting. I'll be joining again the meeting at 7:10. Okay. You people don't leave the meeting. Okay. So have you written this question? The first question, is it done? Hello. The first question. Who asked the first question?
Yes, sir. Yes, sir.
Okay. Okay. Fine. Fine. So you start solving the questions. I'll join the meeting at 7. I'll start the discussion at 7:10. Okay. Hello, am I audible? Hello.
Yes, sir.
Okay. So have you solved the questions? Can we start discussing the solutions? Shall we start the discussion?
Yes, sir.
Okay, fine. So I'll start discussing the solutions one by one. The first question was, according to Boussinesq theory, the soil mass is. What is the answer? What is the answer?
Yes, sir.
Yes, homogeneous and isotropic. What is the meaning of isotropic?
It has identical properties in three different directions.
Yes, in different directions it has identical properties. Right. Yes, you can mute yourself. So according to Boussinesq theory, the soil mass is homogeneous and isotropic. That is an assumption taken in this theory for determination of the stress. Okay, so next question. At constant r equals to 1 unit, the vertical stress is maximum at z equal to. What is the answer? What is the value of z? Yes,
1.224.
1.224. Yes, option number is 1.225. So anyway, because of rounding off, it has changed. How do you get 1.224 or 1.225? How do you get that? What is the relationship between R and Z for maximum, vertical stress? What is the relationship between R and Z?
R by Z is equal to 0.817.
Very good. Okay, since the first option is the closest one, 1.224, 1.225, it is the correct option. Okay. So when R equals to 1 for maximum vertical stress, the value of Z will be approximately 1.225 or 1.224 that you have got using this formula. Okay. Sorry. Next question. Yes. At 0 radial distance, the value of Boussinesq influence factor is. What is the value?
Option B, sir.
Option.
B, 0.4775.
Yes, that is 0.478. Yes. How do you get that?
By substituting R is equal to 0
What is the
in
formula?
the KB column. 3 by 2 pi rocket.
Yes.
1 by 1 plus r by z whole square to the power of 5 by 2.
So if r equal to 0, then the value of 3 divided by 2 pi, 0.4774647754778, this becomes 1. Okay.
Yeah, it's also equal to 3 by 2 pi.
Yes, 3 by 2 pi, exactly. 3 by 2 pi equal to 0.478. The value of 3 by
Yes.
2 pi is the value of Boussinesq influence factor when the radial distance is 0. When we are calculating the load directly at the axis of loading, below the load, just below the point load, okay? There is 0 radial distance. Good. So yes, value of Boussinesq influence factor is 0.478 at 0 radial distance. Okay, next question. This, anything you want to say? You can mute yourself if not. Hello. Yeah, thanks. Okay, so the next question was the Boussinesq influence factor is a function of R, Z and Q. Is this statement true or false? Very easy. The Boussinesq influence factor is a function of R, Z and Q. Is this statement true or false? Just solve the previous question.
It is false.
Yes, it is false. It is a function of what?
Only r and z.
As we can see over here in this formula, only R and Z, radial distance and vertical depth. Okay, so the Boussinesq influence factor does not depend on Q. There is a load. It is only function of R and Z, R being the radial distance and Z being the depth. Okay. Okay, next question was the change in vertical stress in a soil mass estimated by Boussinesq equation when Poisson's ratio of the soil reduces by 20% will be. What is the answer? What is the answer?
No change, sir.
No change. Why? And where can we see the change?
In the previous formula, there is no any Poisson's ratio.
Yes. So this Boussinesq influence factor, it does not depend on Poisson's ratio. Okay, there is no relation. But Westergaard influence factor, okay, there is a relation with the Poisson's ratio. Okay, Westergaard influence factor. I believe Westergaard influence factor was there in the session 8th discussion session, which is scheduled on tomorrow evening, isn't it? 8th session. So in there, I think I can, if I have prepared some numericals, I will see on Westergaard. In Westergaard analysis, the Westergaard's influence factor, that is dependent on mu, the Poisson's ratio of soil. Kb does not depend on mu, so whether the Poisson's ratio of the soil increases or decreases doesn't matter. Okay, the vertical stress, there will be no change in the vertical stress because there is no relationship between the Boussinesq influence factor and the Poisson's ratio of the soil. Okay. Okay.
Sir,
Yes.
can you take up the same question in Western Ghats by next week or whatever maybe, including Poisson's ratio? Possible?
I'll see. I had already the questions were already made last week, but due to some
Okay.
due to my ill health. I'll see if I can add. I'll definitely do that within the time span if I can see.
Sure, sir. Thank you.
Okay, yeah.
Hmm.
Okay, so the short questions are done. Now the numericals. Just a moment. Yes. Yes, circular area of 7.5 meter in diameter, ground surface, UDL of 3 kN per meter square, intensity of vertical pressure below the center of the loaded area at a depth of 6 meter below the ground surface. Have you solved this question?
One 1.171 kPa, sir.
Okay, how do you solve this? So this is the circular area side view like this. Well, this is the circular area at a depth of 6 meter. Okay, we can solve this problem in two ways. I'll show one way over here using the main formula. The other one I'll be showing in the next formula, in the next sum problem. Okay, so if this is 7.5 in the radial distance, the radius is how much? 3.75, isn't it? 3.75, and this is the value of A, and 6 Z equal to 6, Z equal to 6. The UDL Q is the UDL, which is equals to 3, isn't it? So what is the formula for finding out the vertical stress? Sigma Z equals to Q, that is the UDL 1 minus 1 divided by 1 plus A by Z whole square, the part in second bracket, yes, the part in second bracket, whole to the power 3 by 2, isn't it? You solve it like this, you can get a value approximately as you have mentioned. Sigma Z equals to equals to 1.17 kilonewton per meter square. 1.17 kilonewton per meter square, isn't it? So I think you have solved this using this formula or the other formula, which takes the angle.
The other formulas. I used other formula.
Yes, that is easier, right? Finding out this angle and using
Yeah,
it.
it's only mathematical conversions only.
Yes, so this angle was how much? I think this angle is 32 degree, right?
Uh, that angle, I
This
forget,
half,
sir.
then how, how did you calculate if you forget the formula?
Tan inverse 3.75 by 6, sir.
Tan inverse 3.75 by 6, and you put the entire value in the equation. You didn't calculate the angle. Yes, it is 32. And sigma Z equals to Q into 1 minus cos cube theta, right?
I use that formula, sir.
Yes. Into Q is 3. 1.171, yes. So I'll be using that formula in the next sum, because in the next sum I think. So this equation is clear. This methodology is clear, I believe, for circular area with UDL. Just to remember the formula and nothing else. Okay. So I'll be going to the next sum. The answer is 1.17 kilonewton per meter square. Okay. Yes. Next sum. Circular area loaded with uniform load intensity of 100 kilonewton per meter square at ground surface. Calculate the vertical pressure at a depth at a point P so situated on the vertical line through the center of the loaded area such that the area subtends an angle of 90 degree. Have you solved this sum?
Yes, sir.
What is the answer you have got?
64.64.
Yes. So here 90 degree is mentioned, although it is not looking 90 degree, but please excuse the drawing. This is 45 degree, this angle. Okay. So Q is equals to 100 kN per meter square, and theta is equals to 45 degree. Okay, theta equals to 45 degree. So now sigma z equals to q into 1 minus cos cube theta. Put the values in this equation, you will get approximately 64.6 kilonewton per meter square. Okay, so this circular loading you can solve it in two ways have been shown over here, but in the previous sum, you see, you can solve it in any way. Okay, because you can always find out the angle, but in this sum the depth is not given. So can you solve it using the previous formula?
Yes, sir. By taking A by Z is equal to 1.
A by z
1
equals
by
to 1.
1 by
Yes,
1.
yes. Why? Because the angle is 45 over here. So here tan 45 means 1. So base equals to height. So A by z over here equals to 1. Very good. So if you put A by z equals to 1 over here, you can also solve it using this formula. Anyway, this formula is something which reduces to this formula trigonometrically, isn't it? I
Yes,
think you
sir.
are aware of that. Yeah. So there is no issue. Anyone will be accepted. Okay. It is not looking like in this diagram that A by Z equals to 1, but again, just excuse the drawing. The concept is important. Okay. So using this formula, I can say that the value of the vertical pressure at a point P is 64.6 kilonewton per meter square. Okay. Okay. Next question. Just a moment. Yes. Concentrated load of 200 kilonewton acts at the ground surface. Find the intensity of vertical pressure at a depth of 10 meter below the ground surface and situated at the axis of loading. Then you have to find the vertical pressure at depth of 5 meter and a distance of 2 meter from the axis of loading. Yes. So have you solved this, and what is the answer you have got for the first and the second scenario? Hello.
No, sir. I didn't solve it still.
You haven't solved this. Why? This was easy. So what is the formula we should
It,
use? It is like you could not solve it, or there was no time to solve this.
I took a coffee, sir, in between. That's
Okay, okay, no problem.
otherwise I can do it. No problem.
Yeah, yeah, I know that you can do it because this is a simple sum. What is the formula? Just tell me the
I
formula.
used a Boussinesq formula. So I am using a Boussinesq formula right now.
Yes, yes, using this formula. Okay, you do it. I am also doing it. We'll solve it together. So the main formula is 3q by 2 pi z square. 3q by 2 pi z square 1 divided by 1 plus r by z whole square whole to the power 5 by 2. Okay, whole to the power 5 by 2. Over here, okay, there are two scenarios. In the first scenario we have situated at the axis of loading, so r equal to 0, and the depth in the first scenario is z equals to 10. So when r equal to 0, this one is just 1, putting z equals to 10, 3q, q is 200 by 2 pi z square, 2 pi into z means 100, this z square is 100. You get the value of sigma z for this case. I think it is approximately 0.955 or 96, whatever you can take, kilonewton per meter square. Okay. Now in the second scenario, radial distance r equal to 2 meter and z equals to 5. So again putting the value, in this equation, the general equation, the value of effective stress, vertical pressure at a distance depth of 5 meter and 2 meter from the axis of loading will be equals to approximately 2.64.
63.
Yeah,
64.
2.63 is 2.64. Okay, rounding of issues won't be counted, it's okay. So only one formula, this is the Boussinesq equation for finding out the vertical stress, 3q by 2 pi z square into 1 divided by 1 plus r by z whole square whole to the power 5 by 2. Same formula I am using in two scenarios. First case r equal to 0, z equals to 10, and second case r equals to 2, z equals to 5. Okay. So we are getting in the first case 0.96 approximately kilonewton per meter square, and the second case 2.64 kilonewton per meter square, the magnitudes of the vertical stress in the two scenarios. Okay. Okay. I hope it has recorded. Yes, it has. Fortunately, yes. So the next question, I'll go to the next question. Yes. Rectangular area 3 by 1 meter uniformly loaded with load intensity of 100 kilonewton per meter square at the ground surface. Vertical pressure at a point 4 meter below one of its corners. Have you solved this, and what is the answer you have got, and which way you have solved it?
By using a single Boussinesq point load, answer is 6.22 kPa.
Yes, 6.22 kV using single Boussinesq point load. Anyway, you have used that, so I will be showing you the other method. Okay, using M and N. So this is the rectangular area where suppose this is A and this is B. Z equals to 4, isn't it? Z equals to 4. So you can find out M equals to A by Z, which will be equals to, I believe it is 0.75, 3 by 4, M is 3, 3 by 4, 0.75, and the value of N equals to, it will be B by Z, which is equals to 1 by 4, that is 0. This is Z, okay, not 2, this is Z. This is equal to 0.25. So once you get the value of M and N, you can find out the value at the corner, okay, using a single formula which is very long and quite difficult to remember, but since you have solved it using the like equivalent load formula, right? You are just converting the entire UDL into a point load at the center, isn't it? Like 100 kilonewton per meter square becomes 300 kilonewton cube, right? So that is the way you are doing it, and you are placing the entire thing in the Boussinesq equation, isn't it?
Yes, sir. Yes, sir.
Yes, like 3q by 2 pi z square. So 3 into 300 divided by 2 pi into 16 bracket 1 by 1 plus r by z. What is the value of r? R will be equal to, I guess, root over of 0.5.
1.58.
Yes, 1.5. Very good. 1.58, and z equals to 4 whole to the power 5 by 2, 6.22. Yes, but this formula, it is quite difficult to remember. Anyway, you will be getting a precise value. Okay, you will be getting a more precise value using this formula. So this is the UDL Q divided by 4 pi. okay, divided by 4 pi. Now first it is 2mn in bracket m square plus n square plus 1, this one whole to the power half, that is in root, only the bracket part, divided by, this is m, divided by m square plus n square plus m square n square or mn whole square, whatever you can write, plus 1. This factor will be multiplied by another similar factor but a small one, m square plus n square plus 2 divided by m square plus n square plus n square plus 1. Okay. Now there will be an addition part where it will be an angle, that's why I am using tan inverse, but this angle needs to be converted into radian. Okay, very important. This angle needs to be converted into radian. I will use a bracket over here. Again, like the previous part, in the first part it will be 2mn m square plus n square plus 1, the bracket part whole to the power half, which is in root, divided by m square plus n square, over here minus m square n square plus 1. Okay, bracket close and then third bracket closed. You have seen this formula, right? Anywhere, I believe you have seen this. Have you seen this
Yes,
formula?
yes, sir, yes, sir.
Yes. So if you solve this very carefully, step by step, this part, the tangent tan inverse part, see, you will be getting an angle. Okay, the angle you have to convert it into radians. That is very important. If you don't do it, you will get a wrong answer. So this part, the value approximately will be 0.2921. Okay, this middle part, that is the product part, this one you will be getting approximately 1.6154. Okay, and the first part you will be getting approximately 0.2879. Okay, now you solve this, your answer was 6.22. I think using this formula you will get the value of sigma c approximately 6.025. The actual answer given was 6. Okay, so the more tedious method you use, the less number of approximations are involved and the more accuracy you get. Okay, anyway, your way is also right. I have also solved that in that way. It is 6.22, it is correct. You can solve it in both ways. I think there is another sum like this. I will be solving it in your way using the equivalent load method. So is this method clear to you?
Yes, sir. I have used a chart here.
Yes.
I
Okay,
got
using
5.5
yes, yes,
kilonewton per meter.
5.5
Yes, sir.
using the
Because
chart.
it is the intermediate value. No, I need to interpolate.
Yes,
I,
interpolation
I,
will
I
be there.
used
Yes,
the
yes. But the
I
thing
used
is,
the approximate.
yes, but the thing is, like in examinations and all, this formula, even if you can remember the formula, you can remember the chart, and chart has to be supplied to you. Okay, the
Yes, sir.
chart has to be supplied to you. Anyway, Okay, so this file is not saving. Just a moment, let me check. Yes, save as. And just write over here solved. Do you know how to handle this issue which I am getting over here? Can you see the issue which I am getting over here while saving the PowerPoint? Hello, am I audible?
Yes, sir. What is happening, sir? Actually, slide.
Uh, yeah, when I'm doing this, you can see the solution over here, right?
Yes,
In
sir.
ink, you can see the solution over here also. But if you see the, this is the slides, you will see that the solutions of 9 and 10 are not visible over here.
9 and 10, it is visible for us.
In the main slide it is visible, right? But here in
Hmm.
the side is not visible, and right now
Okay, okay, okay.
there is a problem in saving this file, and this one I also have to upload. Anyway, in the recording, in the recorder it is recording,
Yes,
but
sir. It was.
it is
Mhm.
recording, but I'll see just a moment. Okay, to keep you save the presentation with a new name or in a different location. Let me go for a different location. I think that might help in downloads.
Page up will not work, sir. Page up or arrow mark up
Yes,
other than
yes.
cursor. Page up button.
Page
Page up, page down.
page up, page up, page down, because I think page up, yes, I have page up. Yes, page down is this. I can see the solution, but in the
Uh,
sidebar where this
Sidebar, it is not
it is
visible.
not
Okay.
visible. See, up till here
Yeah,
it is
yeah,
visible.
yeah.
Anyway, I will.
It is not only 9, sir. After 9, nothing is visible because you didn't solve still.
No, up till 10 it is solved. See, up till 10, 9
Uh,
and 10 it is solved, but then
uh,
from here it is not visible. So I'm afraid that if I go on, you know,
hmm.
doing this, so
Maybe we'll check after 11th example, it will come out automatically or not.
that I have to see, that I have to see. If I close it right now instead of saving, then everything will be gone. That is my, fear.
Hmm.
Anyway, let's check by closing it once. Okay, we have time till now. We have time, and the rest of the sums will not take so much time. Okay, let's check it once because I cannot risk it not recording at all. Okay, let's close
Okay.
it and let's open it once. Save as. So okay, I'm doing save as, but I'm, yes, save as. No, then solved. Don't save. Recent copy temporarily available. Let's see. Yes, see, recent copy is not available, so everything is gone. Can you see everything is gone?
It is already recorded, na, sir. All.
Yes, it is recorded, but you also have to upload this, the solved PPT in the
Okay.
Google Drive. Okay, so okay, no
Mhm.
worries, no issues. I'll just start. The first one was A, right? First one was A. The second one, please repeat and please help me out in this scenario.
You can share the screens.
I have not shared the screen. Oh, okay, okay, fine, fine, fine. Wait.
Got it.
Yes. So I think it is visible now. Yes.
Yes, sir.
So this one was false. This one was false. It is the Boussinesq influence factor was I have written over here the function of R and Z, right? R and Z. Okay, now I'll just try to save it. It is saving. I'll just go on saving it time and again. Okay, this one was no change because uh, the Boussinesq influence factor does not depend on the Poisson's ratio, so no change. Here, what was the formula? The formula was for the vertical stress. The formula was, I used the formula Q into 1 minus 1 divided by 1 plus A by Z whole square, isn't it? This one whole to the power 3 by 2, right? 3 by 2, where A was equals to 3.75, and what was the value of the Z? Z value was 6.
6
6,
meters.
yes. So sigma Z was approximately equal to 1.17, right? 1.17 kN per meter square. It will be over in a minute. I'll just save it now. Yes, I'll just save it. Okay, see, again there is an issue. Yes, 1.17. Okay. Okay, now it was a circular load, subtends an angle of 90 degree. So the value of this theta was 45 degree. This diagram is better than the previous one. Anyway, theta is equals to 45 degree. And what is the value of Q? Q equals to 100, isn't it? So the formula was sigma Z equals to, please let me know if I have forgotten something. Okay, 1 minus cos cube theta, right? The value, what was the answer? 64.64, right?
Yes,
64.6
sir.
kilonewton per
Kilo-
meter square. I'll again save it once. Okay, file has been saved. Next one was the concentrated. This one was okay. It was like this sigma Z equals to 3q divided by 2 pi z square into 1 divided by 1 plus r by z whole square whole to the power 5 by 2. There were two scenarios. The first one where r equal to 0, the first one where r equal to 0 and z equals to 10, right? The value for sigma z was how much? 0.955 kilonewton per meter square. Is it right? Am I going
Yes, sir.
okay?
Yes, sir.
Okay, and a distance of 2 meter over here, z equals to 5. So the sigma z value over here, I think it is 2.64. Yes, 2.64 2.64 kilonewton per meter square. Okay, I'll again save it. The file is saved. Now number 10. Number 10. Okay, now I have to write the entire big formula, but anyway I have to do it. So the value of m will be equals to a by z, that will be equals to 0 0.75. The value of n will be equal to b by z, that will be equals to 0.25. And how do I get the value of a and b? This is a, length is to width. So a equals to 3, b equals to 1. That is the way you get it. Now the value of sigma c, which I have used over here, will be equal to the big formula where the UDL is there, divided by 4 pi. Next it will be 2mn m square plus n square plus 1 to the power half divided by m square plus n square plus m square n square plus 1 into m square plus n square plus 2 divided by m square plus n plus n square plus 1. This one added to tan inverse, I'll write over here 2m n m square plus n square plus 1 whole to the power half divided by m square plus n square minus m square n square plus 1. Is it right? Is it okay?
Yes, sir, it is
So
okay.
till now it is okay, and by solving this, I am not writing it by breaking down the individual components. The load at the corner will be approximately equal to how much I put in 6.025, right?
Yes, sir.
6.025 kilonewton per meter square. Okay, so I'll saving it once again. Okay, now it is saving fortunately. Okay, so till now it is visible and it is recording. I believe it has recorded anyway. I'll be doing the next sum right now, number 11. Okay, so this one was the infinite length line load. How to solve it? So this is the width. Okay, this is the width, angle subtended at the center. Okay, here total width is 10 meter, so individual is 5 meter, this is half is 5 meter. The depth also 10, depth also 10. So what is the value of theta? Theta is the entire angle, isn't it? This entire angle is theta. If the half angle is alpha, then what is the value of alpha? Alpha will be get by solving 26.57 degree. Okay, so theta will be equals to 2 alpha, that will be equals to approximately 53.14 degree. Converting to radian, okay, 0.927. Now the formula for this one is sigma z. Have you solved this, by the way? I'm just going on.
Yes, sir, I have done, sir.
What is the answer you got?
81.83 kilopascals.
81.83. No, please check. The formula is q by pi theta plus sine theta. Okay, theta plus sine theta. Theta is 0.927, sine theta is sine 53.14. Q is 100 and pi. The value approximately will be 54.98, 54.7, 54.6 to 55, something like that will be. So I'll be writing over 54.98, the value I've got. Okay, this will be the value. Okay, you solve it. Afterwards you can solve it also. Okay, I'll be uploading the PPT. I'm going to the next sum right now because it has taken some time. Have you solved this sum? Maximum vertical pressure on the vertical plane?
Yes, sir, 2.2, sir.
Yes, 2.2. How do you solve this?
By taking R by Z is equal to 0.817.
Yes, so the value of R by Z equals to 0.817. So if R equals to 2, right, Z equals to 2 divided by 0.817, that will be approximately how much? 1.225, sorry, 2.45, right? 2.45 approximately, isn't it? You're getting the value.
Yes, sir, yes, sir.
Yes. So again, in the Boussinesq formula, sigma z, here I'll write max because it is the maximum value of stress. That will be 3q divided by 2 pi z square. 1 divided by 1 plus r by z whole square, this is z whole to the power 5 by 2, z equals to 2.45, r equals to 2, we get a value of approximately 2.22 kilonewton per meter square, isn't it? 2.22. Okay. Okay, So next sum will be, yes, this is very easy. How do you solve it? How do you solve this?
It's the ratio of z by z sir, whole square.
Yes, sigma z is directly proportional to 1 by z square, inversely to z square, isn't it? So sigma z1 by sigma z2 will be equal to z2 by z1 whole square, isn't it? What is z2? 5, z1 3. So it will be 25 by 9, approximately equal to 2.78, isn't it? Is this the value you have got?
Yes, sir.
Yes. So only the ratio of the vertical depths. Okay. Okay. Next sum. Rectangular area. This one I will solve with the equivalent load method. What is the answer you have got? Center and the corner. So this is the loading area 2 by 4. Okay. What is the radial distance from towards the corner? For the second part, r equals to root 5, isn't it? So at the center it will be simple as 3q divided by 2 pi z square. What is the value of z over here? 5, isn't it? Z equals to 5. What is the answer in the first scenario? And what is the value of q? Sorry, what is the value of q? Q is equals to UDL into the entire area, right? So 4 to the
64.
yes, 64. This is an important conversion which was almost missing. Now it will start refreshing. I don't know. Okay, it has closed. Close it. Till how much I have done? Okay, that part didn't get saved. Delete. What was? See, this is the issue with online teaching.
Yes, sir. Yes, sir.
It was 2.78, right? Previously.
Share the screen, sir.
Oh, okay. Wait. Okay, there are two PPT opened. Here also. Just a moment, huh?
Okay, sir.
The file that has been recovered, that was showing now after multiple times saving. Okay, so here I was writing, this is the area 2, 4, the radial distance r will be equals to root 5 for the second case scenario. Value of q will be equals to 2 into 4 into 8, that is equals to 64 tons, isn't it? 64 tons. Now for the first case, that is at the center, it will be 3q by 2 pi z square. Okay, 3q by 2 pi z, because r is equal to 0, and the value will be getting over here approximately 1.22 ton per meter square. Please check it. I think this will be the value. And at the corner, the big formula, the main formula, 3q divided by 2 pi z square, okay, 1 divided by 1 plus r by z whole square whole to the power 5 by 2, okay. R is equals to root over of 5 and z in the two scenarios, z equals to 5, right? Z equals to 5. So have you got any value? I think I am getting 0.77 over here.
Yes, sir. Same.
0.77 ton per meter square.
Correct, sir.
Yes. So this is the value. Okay, rectangular area. I have solved this using the equivalent load method. Now, next one. This
Save
one,
it, sir. Every question.
yes, I am saving it right now. I am just going on pressing Ctrl S and Ctrl S. I cannot risk it anymore. Solving it all together again, all over again. Yeah. So what is the how to solve this question? Have you solved this? So I'll just divide it. Okay. First scenario, second scenario. Yes, you can speak.
Done, sir. I have done it. No problem.
Yes. So at the center, when the first scenario is the center, right? Directly below. So it will be 3q divided by 2 pi z square. Again, what is the answer? You've got q is equals to 20, z equals to 4. Answer is
0.59.
0. I've got 0.597. Okay.
Yes, sir. Same, sir. 0.597.
597 kilonewton per meter square. Now, what is the value of horizontal shear stress? Tau.
0. 0.
Yes, the formula is sigma 0 into r by z. Here r equal to 0, so it is 0. Okay. In the next case, sigma z at 2 meter. That will be again 3q divided by 2 pi z square 1 divided by 1 plus r by z whole square whole to the power 5 by 2. What is the value you have got over here? Putting r equal to 2 and z equals to 4.
0.341.
0.341, yes, 0.341 or 0.342, as I've got, anything is right. Kilonewton per meter square. Now again the shear stress, same formula, it is sigma z at 2 into r by z, r equals to 2, z equals to 4. It is half of that, 0.171 approximately.
Yes,
0.170 or 171. Yeah.
Yes, sir.
Kilonewton per meter square. So the thing different over here is we are calculating the horizontal shear stress, which is the product of the vertical shear stress and the ratio of the radial distance to the depth, isn't it? So in this way we get tau r by z equals to sigma 0 sigma into r by z. In the first case it is 0, in the second case it is half of the vertical stress. Okay, clear? Last question. Was it recording till? Yes, it was recording. Let me check. Yes. Last question. Have you solved this question? This is very easy. This is a tricky question actually.
Yes, sir.
What is the answer?
4 times 100, sir. 400.
Yes, yes. So it is, the initial block is 1, 1.5. When I am talking about the final one, it is nothing but combination of 4 of the initial blocks, which is 2 over here and 3 over here. So I have mentioned over here some depth below the corner at this point. At this point, the value of sigma z equals to 100. Now this is the block. again this is the same block. So all the corners at the same depth will be exerting how much? 100 each. So at this point P, this point is P, so sigma Z at the point P will be load at each corner multiplied by the number of corners, isn't it? That will be equals to 400 kilonewton per meter square. Okay, is it clear?
Yes, sir.
Yes. Any doubt regarding any question, any problem?
No, sir, everything is clear.
Okay, fine. So this was all about the Boussinesq theory. Okay, and tomorrow from 6 to 8 I'll take the pending class last week, that is the session 8. I think it has flow nets and stress distribution in soil. Okay, so I guess I'll see you tomorrow then. Just a moment. Yes, so thank you for attending the class. I'll see you tomorrow with the 8th discussion session. Okay, thank you.
Thank you, sir.